Hi and welcome to another demonstration of the Steel Detailer. This demonstration that we are doing tonight is going to be about adding to the library and how we can do that and then manipulate what we've got in the library to create projects. There's a fair bit to cover in the next half an hour to an hour, so I'm just going to start from start to finish. If you have any questions, please send an email to support at the Steel Detailer. There are a few of you online. If I opened it up to discussion, it would slow the video performance down, and also we'll keep the topic on. So let's get started. So let's just go through the menu facilities as far as the library goes. I guess we'll start from the smallest to the largest. If you go to the TSD connections, there's a plate library. Okay, there's also a connection library. So these are your stock standard basic connections that we use on a regular basis, and they're shortcuts to a library filter. And the next part of the library is a parts library. In there you can put items in such as WebForge hand railing and components and things like that, or even driving sketches, and or even equipment that you may have modelled up that you want to put into a mining project that you may be working on. So that's the parts library. So that's one of three, and then there's the members library, which in the members you can have driving sketches, or you can have beams with complete connections, columns with connections, and concrete panels and things like that. These are just shortcuts again to stock standard items that are in the library that we can reuse. And also above the members library, there's another one called an area library. Now, an area library itself is can be a complete project or part of a project. So if you imagine you've got a complete building that you've modelled up, and you just want to put it in the library because you may do the same building over and over again, and all you need to do is just change out the steel section sizes and change some of the dimensions. So that particular library itself is quite powerful because it, as you insert it into a project, it renumbers everything and renames it, including the drawings. Right, so that's just an overview of where the connections are. Where the members are, where the library members are, where the connection components are in the library, and your plate, and obviously the parts in your parts library. Okay, so I'm going to start from basics. So I'm just going to start with creating plates, and creating the plates themselves is quite a simple process. And then I'm going to go into connections. So I'm going to use the plates from the connections to create from the plates library to create the connection, and then I'm going to insert the connection into a member, and then I'm going to create the member and then insert it into a project area. Okay, and I'm going to do all this starting from scratch outside of the Steel Detailer. Now, SolidWorks, in its infinite wisdom, gives us pretty much a wide open space for us to model. So without TSD, you can actually create your plates, you can create your connections, and you create your members. And there are rules that you need to follow so that you get the same sort of result all the time. Now, plates are simple as long as you follow the rules that are associated to it. Connections are a little bit less rigid, they're a bit more flexible. There are rules, and if you go into your members, there's a pretty strict rule set up for that. Now, the reason we put the rules in is because we want our libraries to come in every time and work every time, and we've got a pretty strict regime at the top level. Alright, so let's start with creating plates for the plate library and move on. Now, you can start a new part and save it into a location, and there's a naming sequence. Now, there are rules for plates. What I'm going to do is I'm just going to show you how I can actually start the process. So I'm just going to minimize my SolidWorks. Now, I've created a folder here, and in the folder I'm going to I've called it layouts, so you can do your layouts, so plates, and in here I'm going to store my plates, and in my connections I'm going to store a base plate. I'm going to use the same plate. So the reason I've created these folders is because I want to put plates in there so that I can use them, and I'm going to put connections in there so that I can use them at some stage. Now, my layouts, if I go into plates, if you're going to create a plate from scratch, there is a certain naming convention and the folder has to match. Now, the first 4 X's that I'm putting in place is a project number, and then I'm going to put in the area code, and then I'm going to put in the beam number or the column code, which is a 2-digit code. Now I'll get into this a little bit more in detail in a moment, but I'm just get you to follow. So this is what we call a member name, and then for a plate it's a P and then a 01. Now I'll go through the different codes that are associated to it, but if you're going to create a plate, you need to put the plate into a folder and match it. Alright, so I'm going to save my plate in there. Go back to SolidWorks, and I'm going to start a new part. Now I'm going to click on a template that I've already pre-created. It's a millimeters units, and in there I've also got plain carbon steel set up. And I'll just get that out of the road. So for plates, and every plate that you model in TSD, you model it so that the actual sketch is on the top plane. Alright. Now this is a central sort of a plate, so I'm just selecting the centered rectangle, and I'm picking the center, and I'm just going to drag that out. Now I'm just going to set this up with some dimensions. I've just right mouse clicked there and selected the dimension across, and that allows me to start the process. So I'm just setting up some basic dimensions here. Now this plate, you could link the vertical and horizontal lines to make it so it's square, but I want it to grow in certain directions, so I've left it so I've got both open. Alright, so now that's just started my sketch, and now I'm going to extrude it. Now with plates, you can make them out of flat bar weldment pieces, or you can make them out of extrusions. Either way is fine. In this instance I'm just going to go with an extrusion, because I find that I can manipulate a plate, whereas with a flat bar I've got one distance that's confined, and then I've got to go and use weldments to change the flat bar, whereas plates I've got a lot more to fiddle with. Alright, now you can have your plates set up so that we're mid-plane, so that's on the center, or you can set it up so that it's above or below. By default I usually stick to above, being base plate. It's however up to you on how you want to do this. Now I'm just going to make it 20mm thick and then extrude it. So now I've got my boss. Now I've started the plate. Before I go too far, I should actually save the plate. So I'm just going to save it. And if I go to my desktop and select my layouts folder and go to my plates, I've created that file name there. Now I'm just going to copy that, because what I want is my plate to match the name. So I've just copied the folder and pasted it in the file name so that they are identical. And if I click save, now I've got my part started. Now on the top plane, I'm just going to put in another sketch, and I'm going to make this my driving sketch for my holes. So I've done the same thing again with a rectangular centered sketch, and what I'm going to do is just make it all for construction, so that I'm not getting confused that there may be an extrusion at any stage. And then I'm going to put in edge distances, so that if I change the plate's dimensions, the plate's holes will move with it. Okay, you can set that up any way you like, and I'm just going to give it a name: hole center sketch. So I've got that. Now if I click on the top face and select the features tab and go to the hole wizard, I can go in and select the holes, select the standard. In this case I've got Australian standards because I am from Australia, and I've got a hole diameter of 24. What I want to do is I just want to go up to the next surface. That means that on this surface it's going to extrude through to the next surface, and that's it. Now if I click on the positions tab, I can then go around and place my holes. You could just simply draw some holes and make them all the same equal dimension and put a dimension on one. So there are many ways of doing it, but I find this the best because the annotations that go into drawings tell me that there's going to be 4. Alright, so I've just started the plate itself. Now what I'm going to do is just hide the sketch. Now just remember that it doesn't matter what kind of plate it is that I'm going to put in the library, it can be any shape, any form. So just out of that, I'm just going to add another sketch on the top plane here, and what I might do is just show you that you can put any kind of plate in. I'm just going to cut a hole out of this thing, so I'll just define that, make that 100, make that 100, and now I'm just going to cut through on that. So up to surface, actually I'll just go up to next, and that'll fix that problem. And because the plate's got some square edges on it, I'm just going to select the edges that I've got here. You can select this by selecting all the faces and then putting it in. I'm just going to put in a 10mm fillet, so we just got the plate so that we don't have corners like that. Alright, so I've just got a basic plate. Now what I want to do is I want to create a drawing template with it. Okay, to do that, same process as what I did with the plate. Oh, file, new, there we go. And I've also got templates in here set up for a sheet, for A4, for a plate, for my plate template. And you'll notice that my plates come in, and now I'm just going to drop it on the top view. And however you want to dimension that, you can use the SolidWorks auto dimension. So if you go up into here and click the auto dimension and then hit your tick, that'll auto dimension it in some weird format. Okay, I'm just using that as an example. You can dimension it any way you like. For me, I wouldn't dimension it like that, but I'm just giving you the example that you can go down that path and dimension it. Realistically, you'd hope that it would give you the basics, which is the overalls, but yeah, it's not perfect. Maybe you need to fiddle with it a bit, but anyway, it's there. So you can dimension that up any way you like, and that's a default plate. Now I've just hit Control S for save, and you'll notice that the plate name that I've got comes in as the drawing. It's exactly the same name as the plate, so I just click save, so I don't have to do any typing at all. Alright, so now I've got myself a plate, I've got myself a plate template. Okay, now I want to add this to the library. Now when adding it to the library, you want to push it over to the left, because TSD takes a 200 by 200 bitmap, and I've got a widescreen, and the widescreen won't take it all in. Now I can leave it there, or if I zoom right out down there, you're going to get a little snapshot that you can't even see, so you won't even know what it is. What you want to do is bring it in so that it's, you know, right in front of you, right up close, and I'll show you what that is very shortly. So now what we want to do is we want to add this item to a cut list. You're probably wondering why I'm not doing any bill of materials linking or anything like that. That sort of process happens down the track. This is just a template. Okay. Alright, so let's now upload the plate to the library. Okay, what we want to do is we want to, I selected TSD Connections Upload Plate. What we want to do now is just have it default at current open plate, because that's what we want. We can load plates in from a file. We set up files from Quadro, and we can give you a whole plate list that you can load in from one text file. All it is just a text file with the names of all the plates in a folder, and it brings them all in one by one. Okay, if you want to delete plates from the plate list, you go down here and go to the modify existing plates, and it'll give you a list of all the existing plates in the library, and you can remove them as you see fit. Alright, so let's just upload this plate. Alright, so that plate's gone up. It's in the library. Now what we need to do is just see where it is in the library. We need to test it. I've created a project, and I've created a project area. For any of you that are interested in doing that and you want a demonstration on it, I've got some YouTube videos that I can send you to show you how that works and how we've created the area assembly. Now you'll notice there's a 4-digit code, which is a project number, and then there's the area code, which is a 2-digit code. Now what I'm going to do is I'm just going to drop in a blank member in here so that I can test my plate insertion. Okay, now there are certain levels to which you have to be in for you to be in order to place plates. So if I was to insert a plate, it would tell me I can't place it in this assembly. It has to go into a connection assembly or a weldment assembly. Okay, so let's just drop a weldment member assembly in. To do that, if you go TSD members, blank member, and go to a structural discipline here, and if we select say CM for column, okay, we're going to drop a column in, and what we want is a vertical member, so we click on the vertical. Now you can drop in a blank member which has nothing in it, a vertical member or a horizontal member. Okay, so we do that, hit the tick, and that'll put in a blank member for us to use bit by bit, and that didn't copy a drawing across for some reason, but we'll get back to that and find out why that hasn't happened, or we'll just create new ones. It doesn't matter. So now I've got a blank member in here with a vertical member. Okay, now you'll notice that what it's done is it's named it automatically, it's created it and brought in a section. What we want to do is we want to insert our plate that we just created, just to test it, to make sure it works, because whenever you upload to the library you want to test it. Okay, so now we're going to insert the plate that we put in. You'll also notice in our plate library we've got various plates that we can use. Stock standard that comes with any customer's package when they purchase TSD. Now in here you'll notice down the bottom we have our plate. Okay, if you click on the plate and hit your tick, it'll bring the plate in. Okay, it's renamed it to match the column's mark number and filing number, and it's brought the plate into the model, and it's placed it at the origin. Now, the plate itself, if I right mouse click it and go open drawing, the templates come in as well, and you also notice that the file name of the template has changed and the references are all associated to the drawing. So now we've got ourselves a new plate from the library, no links associated to the library, it's part of a project. Okay, now this plate can also be changed, and I'm just going to show you that. So let's just say we make that 600, okay, and the plate itself can be changed so that it becomes a new library component. So now I can just open up the drawing, that'll automatically update, and if you've got that dimension correctly, it would move the dimensions around the right way. So now I've got a plate in my project, but I want to use that plate again because I've now made changes. Okay, so I want to take away those so that they're not part of the package anymore, and I just want a flat plate. And to do that, I basically now have to go back and update the drawing. So right mouse click in a view, and I just take away the dimensions that don't apply. Okay, so now I've got my plate again updated for my template. Now, straight out of the project, you can do the exact same thing. Go to my connections, upload plate, have current plate open, hit my tick. So now I've just added that plate to the library, and for me to test it, let's pull that one out the road and put in a new plate. Connections, insert a plate, scroll down, there's our new plate, and now we can tick it and add in the new plate. So there's our new plate with no hole in it, and of course it's a new instance, so we've got P02, so it's gone from P01 to P02, and now if we open the drawing up, that's linked to P02 to match, and we've got ourselves a new template for our plate. So you can see how quick you can build a plate library from different types of plates. You can go crazy if you really wanted to. So now we've got our plates in our plate library. So that's how you upload plates to the library. That's how you reuse them in your projects. Okay, so we've covered that. What I'm going to do is I'm just going to remove these two plates. If you go into the TSD parts and go delete part, if you select the plate, you can remove it, and what it does is it removes the plate and the file and the drawing. Okay, so now I don't have to worry about the files in the folder. So it removes those as well in one go. So now I've just removed those plates. We'll keep the member because now we're going to show you how to model a connection very simply, because we've got a lot to cover, and I want to be able to do this in the hour to show you how it's all done. Okay, if you want more details, yep, sure, just send us an email and we'll show you how to do a little bit more as far as the connections go. Alright, now a connection from scratch, quite simple. If you go over into our layout area again, okay, we've got our plate. Now what you'll notice is when you uploaded the plate, I should come back to this, it created a bitmap file, okay, of the plate. There's the image. That's the image that came in. So it creates an image in that folder, but when you actually upload it to the library, and I'm just going to show you where the library is kept. By default, I think most people have set up their libraries or their trial libraries in the database area under the Steel Detailers folder on their C drive, and in there you'll find this sort of setup. So depending on how you've installed your trial, you'll have a couple of directories in there, and in here I've got my plate library, and in there I've got all my plates. So our plates that we just uploaded are 19 and 20. If I want to see them, I just go into here, and there they are. Now these are just 200 by 200 bitmaps. I can just go in, edit the bitmap, put some text on it, test, any text I want, and close it. You can even render it. That's what these are. These are renders with SolidWorks' PhotoView 360, and they're saved out as 200 by 200 bitmaps. And now that I've got that test there, I'm just going to go back to show you exactly what that happens by doing that. You'll notice that obviously if I go in, insert a plate, I go over, and the text comes up in the image. So you can call your names, call your plate names. You can even create a catalogue of plates so you know where each plate is, and use your own codes if you want. It's up to you. At the end of the day, it's your filing system. Alright, so I'm just going to go back over to the layout area and get this connection underway. Oh, by the way, this process happens with every library component. If you go into the parts library, pictures, there's pictures in there. If you go into the member library, there's pictures in there, so you can see all the member library components that we've got that you can use, and so forth. Connection library is the same, so pictures as well, they're all in there. Okay, now let's go over to the layouts and start ourselves a connection. So if I go into my desktop, layouts folder, now connections are a little bit more different in the naming convention. I can grab the same name I've got here and go back and go into the connections. Now I've got base plates, so you can, in your layouts area, you can have different types of naming conventions for your connections. Base plate, fin plate. So I've just isolated them so that they are in some sort of organisational process, because this is where your layouts occur. And when you've done your layout, you upload it to the library. You could potentially just remove what you've done here because it's in the library already, and you don't need to come back to it. Some people like to zip this up and put it away, hide it so that it's protected. Alright, so we're going to create a new folder. We save it. Now, connections are labelled like this. So CN, caps, CN01, right? That becomes the connection number in sequence when you insert a connection inside your assembly. Then we're going to go BP01. Now, this is a base plate. The BP is a 2-digit code that we've got in our model filtering system. Okay, now I'm just going to show you what that is so that you can see it. If I go into SolidWorks and go to the TSD projects, we have a connection type filter manager. Okay, in here, if we go to say BP and just double click, select in there and go BP, type it, you'll see that I have base. Now this is a 26 by 26 matrix, A to Z down the left hand side, A to Z across the top, and if you can imagine a spreadsheet where B is and P is, we actually have the name base. Okay, what that means is that we've set up a code for a description. Okay, that code helps us file our items and keep consistency as far as the sizes go. And you'll notice there's all different types of names in there for different things that we've allocated. So there's Perl, and these are all connection abbreviations, connection codes, I should say. All right. So just show you that that's where that begins and finishes. Now let's go back over to the to the naming convention. So it's more than likely you're not going to have 99 different connections in one member and 99 different types of base plates in your base plate connections in your library. If you do, you've outperformed everybody that I know of as far as TSD users go, and we may have to change the code. But at this stage it works quite well. You'll probably find that you'll duplicate some of your connections and you'll get in there and clean it out. Alright, so now I need to copy that name again, because what we're going to do is we're going to drop an assembly into that area. But I won't copy it from there. What I'll do is I'll just copy the path, make it a little easier for me so that I can go straight there. Now if I go File, New, and I go to an assembly, now I already have a TSD assembly set up. It's got weight set up in there and the units. Now I'm not going to bring anything in. I'm just going to save this assembly, and I'm going to paste what I copied before, come back one folder, copy the folder to which it belongs, and then go back in again. And you'll notice that I don't like typing. If I can just copy something and manipulate it, it's much better than typing something, because if you type it, you're going to probably introduce an error there somewhere along the line. Alright, so rules are connection, same folder, same assembly name, just like the plate, same plate folder, same plate name. Okay, if you follow these conventions, you'll be right. Now we've dropped that in, so we've saved that assembly. Now what we need to do is create a new part. Okay, we go back over to the TSD parts again. Now this part is a dummy part. Now I'll explain what a dummy part is. A dummy part is pretty much an expander, a spacer that allows you to manipulate your connections quite easily around main structural steel sections. Okay, we end up hiding them so that we don't use them in our models or in our drawings at the end, but they are there predominantly just to space items rather than using the main sections. We use the main sections as guides to change these. Alright, so now I'm just going to save that in there. Now because it's a dummy member, we have a naming sequence, a DO1. You'll notice that I did a PO1 before. Okay, now a DO1 dummy, P stands for plate, D for dummy. We also have another two. We have V for vendor, which is a vendor item, and we also have M for member. Now what we don't want is certain things happening at bill of materials creation time and custom properties creation time, which means we're going to put in, say for a plate, the bounding box associated to it and its size. I'll show you that in a little bit. Now the dummy member itself has to be labelled D, because it's the code that we use for dummy members in TSD. So I'm just going to save that. So we've got a plate. Now in the plate, I'm just going to create a dummy member. This is a stub, okay? I'm just going to draw a line, and you'll notice that I've drawn it from bottom to top, and I'm just going to make it 300, and I'm going to put a Weldment on it, okay? Before I do it, I always name my sketches. Now if this is a snap-on sketch, which is what we use for TSD terminology, a snap-on sketch is a member sketch. You'll see that when I get to members, to add members to the member library. I do the same thing with parts, and I do the same thing with connections. You may have some bracing member sketch snap-on lines that you have to use to pick up the connections. And in this case, this is a very basic, simple connection. Okay, so we're just going to put a Weldment member in there. Okay, if you haven't got the Weldment members library, please email me. I'll send you a link so that you can insert that. That's free to anybody to use. In that you get the metric sections, and you're able to just go in and grab sections. So I'm just going to grab a UB, and I'm going to make it a 310, and then select the line and put it on. Okay, so by default I'm going to stick to a center, and I'm going to save that. Now what I want to do is I want to bring that in. So if I go to Window, Tile Horizontal, I'm going to bring it into my connection so it becomes part of my connection. I'm just going to close that off and open that up. So now I've got that in my connection. Previous releases you were able to drag and drop straight over the top of each other, and what it would do is it would put origin to origin, but it doesn't do that anymore. It's really disappointing. So now I've got to do it this way. So I've just put a mate in, and that aligned the axis for me. Okay, so now I've got a member. Now what I want to do is I want to bring my plate in, and I can do that here. So if I go into my connections, insert plate, I can go to my plate library and grab the plate to which we last created and insert that into the project. Okay, that plate's huge. It's not suitable for this project, but we're going to change it. So our plates come in, and you'll notice that it's been labeled to match the existing connection information. It's not fixed, so we're going to fix it. All plates are just basically inserted on the origin with TSD, and we position them by mates. Okay, so that's now locked that plate in place. Now let's move the plate and manipulate the plate with the actual stub that's associated to it. And to do that, I'm just going to edit the sketch that creates the plate, and I might bring this down so that that's 300, makes it a bit more realistic. Now I'm going to take that dimension off. What I'm going to do is I'm just going to add, say, 10 mil to my base plate, or 50. We'll bring the holes in and see where they're sitting. Okay, so I might make that a bit bigger, make that 100. Okay, so my holes are out. I've just double clicked on the plate to get the plate to change. So it means that if I change this Weldment member, that plate is going to change to suit it. What you'll also notice, the plate itself is sitting down inside, the dummy member is sitting down inside the plate. What I'm going to do is trim it. Now you could use the Weldment trim tools to trim this part against the plate, but because they're single part items, when you go to do a rebuild, the trim sometimes does not update. The way we've worked out around it is to put a plane inside the Weldment member and put it on the surface so that the plane is actually in context in the Weldment member that I'm trimming, in the section that I'm trimming, and then I just open that up and then trim it using the Weldments. And then because the plane is associated to this item, the Weldment trim remains when you do a rebuild. So if I was to, I picked structural member there, go to the trim, select the face, and I don't want to allow the extension, I want to take it. So it's got discard keep, that's exactly what I wanted. So now if I double click on my plate, blow it right out so that it's something astronomical. So let's just go to, say, a 50 mil, that'll stick out. You'll notice the trim has occurred on the member. Alright, let's put that back to 20. Alright, so now we've got that set up. Now, this stub, if we actually drive this stub in our connection, you'll see it in a minute, it will drive the plate. We've set it up to do that. Now, we just want to make sure that our drawing is going to be free from burrs, and our template burrs, what I mean by that is I don't want it falling outside the actual drawing view because it's too big or too small. I could actually blow that up, make it a bit better for the detail. Now, what I want to do is now upload this plate. Before I do that, I like doing a bit of housekeeping. Dummy components themselves are excluded from the bill of materials in all instances because we don't want them coming in. Okay. Also, too, with that in mind, you want to make sure that when we do our modeling updates, make sure that your mass, when you do your mass, no matter what happens, you make sure that this is unticked where it says include hidden bodies and components in the mass, because we don't want the hidden bodies coming in, okay? We want them taken away. So just make sure you click on that to get rid of any unwanted bodies or parts or anything that we want hidden from the bill of materials. Alright, so that pretty much sets that up. So now what I'm going to do is just add these to folders. I go dummy part, caps, I like caps, dummy part. That just puts it into a folder. And now we add this one to a folder, and we'll just call it plates. Now you could put some bolts in here. I'm going to run out of time if I put bolts in. I've got lots to cover as far as the rest of the library goes, and I just want to make sure that you get a fairly good understanding. Now, as I said, you can put other plates in here, gussets, drop gusset plates in, position them, put your your holding down bolts in, which just could be a simple cog. I'll put one in for the sake of it so that you can see. If I go nuts, I can put more in, but just one. Now we've got a library in TSD that we've created in the folder, in the main root folder. If we go into the Steel Detailers folder, in there we've got fasteners, and in there we have an M20 holding down bolt, to which you can actually just simply drag in. Okay. Alright, so that holding down bolt, I'm just going to position it. You could put smart component, smart mates in place. It's up to you and how you want your bolts to work. We've just placed them in there as a dummy component, and I've set it up so that it pretty much just sits there. You can have the whole bolt completely set up so that it gives you all the information, nut, bolt, washer, the whole lot. And I'm just going to make this so that it's parallel. I'll just hit my S key there. Parallel. There's my bolt in place, and obviously if you double click on it, I've got the depth and everything in there. Now this is actually a read-only file. Now with fasteners that we use in TSD, they become virtual components. So we make them virtual. That way they snap off and they're not looking outside the folder, which is what you have to make sure of. Okay, it's one of the rules with TSD. If you're working within a folder to create a model, everything has to stay and remain inside the folder as far as references go. Now, this is a holding down bolt. You also have to exclude it from the bill of materials. Now, there's a reason for that. I'll get into that later. It may not be covered today, but it is a rule. You make it excluded from the bill of materials, because what TSD does is it picks it up, puts it into a database so that you can produce a bolt schedule. The virtual component and the excluded from the bill of materials is a filter for TSD to pick up the actual bolt itself. You'll also notice the name of it, M20 bolt. Now you can name your bolts any way you like, but you need an M in front. Okay, M16, M12, as long as you've got the M in front. Now it works for imperial, so if you want to go M ½ inch or something like that, the M is an instigator to let TSD know that that is the actual bolt itself. What comes out in your bill of materials is the configuration name of the object. So if I right mouse click, M20 holding down bolt, 600 long, grade 8.8 S, complete with nut and washer, and a cog. Okay, so that's the actual config name that comes into the bill of materials when we do a member lock. Okay, so we've got one bolt in there. I know it looks pretty silly. We could probably just go around and go like this while I'm at it. Copy with mates. Pick up the concentric, coincident, and just go nuts. Tick and tick, and so I've just put some bolts in there. Now you can go in and have a look at these guys and see how they're mated, and just do a quick flip. So flip, that turns the bolts around the other way, and flip on the front plane. Alright, so now we've put those in, just for picture of sort of reasons. Now, we've got our bolts. So I put those in a folder just to keep things neat. I call it fasteners. Okay, so there's a connection, a really simple connection. There is no driving sketch at the top to actually drive the length of this member, because this member is just a stub and we're not snapping it onto anything. Now if I had cleats coming off this to pick up connections, I would have member sketches in here. I'll show you another example of this connection very shortly. Okay, so let's put this into the library. Of course, we need to zoom right in on it. We want to make sure that all of our plate drawings are okay. That looks okay, because all the plate drawing templates get uploaded to the library. So let's go into our connections and we go upload connection, and we do the same thing we did for the plate, current open connection, and we need to set our filter. So we're going to have a base filter. Okay, click the tick, and that's now uploading the connection to the library so that we can use it. Now we need to test the connection and make sure it's going to work okay. So now we can close that off because that's old now, it's in the layouts area. We've now got the connection in our library. Now for us to start a connection, and if you've only got one piece of material in there that you can, or a weldment member that you're going to put the connection into, you actually have to have two, okay, by rule. It's just the second selection for TSD to know that there's something else that it may be connecting to. It's for future releases. At the moment, it's just there as a prerequisite. So what we want to do is we want to make sure that this column here that we're working on, we'll just fix it. We're in a play area. I've set this up as a play area. I've put in this dummy member which we put in before, and we're going to drop a connection into it that we just created. So now if we go into our connections and we go base plate, you'll notice that our connection resides at the bottom, okay, because it always appends the last connection to the list. And I'll click on that. Now what I want to do is pick the origin and then the member and then another member. So just be wary that we need to put two members in. So all I'm going to do right now, and I've just exited out of that, is just select this one, hold the control key down and drag another one out, just temporarily. So now I've got the same member twice in there with an instance. Okay, I'm now building a member off to the side. It's not part of a project, so I'm just building it off to the side. So now I'm just going to drop a connection in, a base plate connection. Scroll down, select the base plate we want, click the point to which we're going to insert it, the member it's going into, and then the connecting member. Okay, so now we're putting the connection in, and our connection now is inside. Now we don't need that other member, we just used it just to put the connection in to meet the TSD requirements. Now you'll notice that the member sections aren't matching. Okay, so let's make a match. To do that, you go TSD Utilities, Match Weldments, pick the code that you're using. Okay, and in here, if we actually pick the member that we're going to change, pick the member we wanted to change it to, or alternatively you can change it to another member if you like, which is what I'm going to do so you can see the growth. Say 460. I want to include the last section in this because that's going to change as well. And if I hit my tick, that updates that member, updates the base plate, and updates the corresponding member so that they're identical. So now you can see how they relate to one another. Now this member here needs to be trimmed off, so we're just going to use the TSD Utilities Trim Part Weldment, and you need to be in a member to do that. It's a good warning, that one. Catches me all the time. You need to be at a level to which it works, and in this case you need to be in the weldment member level. And if I go back into the utilities and I go trim part weldment, I can select the main weldment and then select the face to which it's going to attach to. Now if you can't select the face, it's just SolidWorks telling me that we haven't updated the connection in SolidWorks itself. You'll notice that I cannot select anything. If you just do a Control Q and a save, then suppress it and unsuppress it, and this is a bit weird, you then can select it. Okay, just letting you know. Now to trim it, let's go back, trim, select the column, select the top of the plate, and that'll put in a trim. Okay, so that's trimmed off the main column to the base plate. So it means now if I double click on the base plate, change the thickness to say 50, the columns member automatically updates based on the trim. Alright, what it did was put that plane in that exercise that we did before to trim the dummy member inside the connection. Okay, so it's done the same thing except that it's done it through coding. Alright, let's change that back to 20. Alright, now we've got ourselves a basic column here that we can reuse over and over again, but we need to cover parts next. The column member's fine, we've got it set up, so let's create a part. Now for us to create a part and to put into the parts library, I'm just going to show you what's in the parts library so that as part of the default custom package. If you insert a part, click on insert, we can create sections. So we've got, I think I've already got one section in here that we can use as a beam member. Now what these are parts that are already predefined and they come with a drawing ready to go. So you can have beams with cuts and copes and all sorts of things in them already predefined, ready to go, along with their drawing fully detailed. Okay, or alternatively you can set up your vendor items and place them in there as well. So we've got WebForge, so here's all the WebForge components, just stanchions at this stage, no returns or anything like that, but you can drop those straight into your project, and I'm just going to show you how that happens. I'm just going to hide this so that you can make that disappear, and I might even just hide the connection. So if I wanted to go in TSD parts, insert a part, go into vendor, select the stanchion, and then web forge. Okay, let's just pick say a corner post. Now when you insert these things, because there's no member sketch inside them, it will just insert it where it is. I'm going to insert it on a sketch point, right? And when you insert things on a sketch point, it does a lock and puts it in a position based on mating planes. Okay, so I've got them all there, so I can flip things around and move them as I need them. So there's the object. All right, that's a vendor item, and with a vendor item, you'll notice it's got the V. You know, I mentioned before we got an M, a P, and in the vendor item, if I open it up, okay, there's a custom property that's already been preset for the vendor item. You can use config specific custom properties, which is what this one's set up as. It's a stanchion type PC and it's got the weight in there. Now when we run our BOM compiler, it will not change that, whereas a BOM compiler will change plate information and member information only, so just remember that. The BOM compiler is in TSD utilities and you run it by clicking on BOM compiler. What it does, because we use single part weldments, that means a weldment in a single-bodied weldment inside a part. It means that what it does is it copies the cut list information out and puts it in the custom properties automatically for you. So we don't have to use cut lists at all. Okay, with TSD we don't use cut lists, we use bill of materials because we're dealing with parts. Okay. Alright, just thought I'd mention that. Now, the actual part that I've just dropped in here obviously doesn't fit within what we're trying to detail here, so I can just delete the part. And if I delete the part by picking it, not duplicate, delete. So go in and hit delete. That's the one with the red X, just remember that. So that removes the part and it takes it out of the back end. So when I go open, you'll notice that anything that's associated to the project is, the assembly is in there. You'll notice some odd little files that have come up. This is because we've labeled these things and we've uploaded it to the library. Okay, just be mindful that that's what's in the folder. TSD skips over those when it doesn't upload, and if I can't even open that, but if I had it open, I could show that that bitmap was a creation of another process that was in play before. Alright, so I'm just unsuppressing and bringing all those items in. Now for a part, right, which is this item here, I'm just going to show you what you can do with a part. If I open up that member, right, I'm just going to remove the external reference for the equal length which this member resides. So it means that I can drag it down and change the length of the member, which is just normal SolidWorks functionality, snapping a weldment on a line. I can then remove the trim for this instance. I'm just doing this as a demonstration and we'll come back and add that later. Now the column itself, if I actually offset that, let's just pick that corner there, that point there, and now I've got it offset, so it means that the actual center line is now running down this edge. Okay, now I'm just going to open a drawing, if there is one, there it is. I can now remove it. I'm taking some dimensions that were here before that I had added, and I'm now just dragging it so that I can effectively have a template for my member. Now what I'm going to do is I'm just going to take notches out of this thing and put some dimensions on it so that you can see, probably around about there. I can put a dimension on this thing from the bottom to position it. Okay, just put 100 mil on there, 100 mil on there, and I might just from the origin sketch from there to there, just give that a 200. So now I'm just say you're going to run say a bit of cabling or something through your column, okay, and I'm just putting a cut in it so that you can see that. Okay, up the top I'm just going to put another sketch line up the top here. I'm going to select the existing sketch that I've got there and pick that edge and just put a slope something on it so that it sort of represents something, 65, and I can put a trim on that. Okay, I'm just showing you that through the processes of me changing this thing, actually I should open that back up again, my fault, that no matter what you do as far as your trims and your sections go, everything comes in play, okay, in the library, so you can reuse it over and over again. I'm not going to go crazy with my dimensioning here, I'm just proving a point. So there's my dimensions, okay, Let's put a 65 in there. So now I've got myself a template drawing that matches the column that I've got in place. Now what I'm going to do is I'm just going to upload this to the parts library. If I go upload part, similar to the connection, similar to the plates, and I'm going to go structural, and I'm going to go sections and TSD. These are filters that are predefined. I'll show you where they are so that you can see them. That's uploading into the library, taking snapshots. Now I've got myself a column in the library. So it means now I can reuse this object. So let's just close that. If I was to say, for instance, just suppress it for now and bring it into this model, just go up into parts, insert a part, set my filters, structural, section, TSD. There's my column stub. When I click on it, because I've got a member sketch line in there, TSD recognizes it and makes it grow to match and links it in place. So we end up with this in contextual reference. Okay, the member sketch that exists inside that part that's come in from the blank member originally has one line in it, and it's drawn from the bottom to the top. It's only one line, and it's the first line that you put in. If you put another line in and delete one line, start the sketch again and recreate your sketch. It has to be the first line and the only line in a member sketch. So just remember that rule. Okay, and we have to name it exactly the same as you see it there in blue, member sketch with a capital M, capital S and a space between them. It's really important you do that. The next member sketch that you can create is obviously sketch 2, sketch 3, sketch 4, so it'll be member sketch 2, member sketch 3, so forth. So you can keep adding member sketches if you like. TSD will only allow you to use 2 member sketches in the automation process. If you create 3, 4 or 5, you can manually snap those on. Okay, that means things like say for instance a set of stairs. When we put stairs in using TSD, we select the horizontal driving sketch, and then we select the diagonal driving sketch, and we pick up the members. We pick up those sketches to drive the whole thing. If you've got, say, a curved beam, okay, from point A to point B is always a straight line. If you set up your straight line in your driving sketch, your member sketch can be the straight line, and the curve that forms the beam, you just snap that onto your main driving sketch manually and making it, say, concentric or something similar. Okay, so you can use other sketches, but be in mind that if you do add a member sketch too, prepare to use it, because if you don't use it, TSD doesn't like it. Okay, we need to use it. If you create a member sketch too and you want it to make it manual, just put manual on the end of it and let people know that it's a manual process. This is just some courtesy tips. Alright, so now we've got ourselves a member that's been dropped in. You can see how that's grown. Obviously, if I right mouse click it, the drawing automatically has updated, and all we do is just drag it. Now, people talk about automated, just alt view, talk about automated sizing and dimensioning and things like that based on the scale of the drawing sheet. What's one right mouse click and change scale going to do? In a minute or two, I've got my drawing updated. Okay, now, I don't want that member anymore, so I'm just going to remove it. So if I go to my TSD parts and go to delete part, I can select that member and get rid of it. What I want is my old member back. Okay, open that member up. I want to put it back on center. I want to take away the cut extrudes so that they're gone. I should have get deleted. Also delete features, I should have selected that. What I also want to do is I want to simply just locate the profile back on the center again, being column. I want to make it centered for this sort of scenario. Okay, so that puts it back over there. Now, by all means, you can change your column and everything as far as its position goes. In this instance, for this particular situation, I'm making it match. Okay, so now I've got that. What I want to do is just open the drawing up that's got that. Okay, and in here I've just got some basic dimensions, and this thing hasn't been set up properly as a template because I've just been modeling it from scratch. So just take that in mind. Okay, so I'm just removing some of the center lines, and you'll also notice that the bolts have come in. Now, to get rid of the dummy components in your drawing view, TSD Utilities, hide excluded components in drawings, and that'll just remove them so that you don't see them anymore. And that should have done that. For some particular reason it hasn't. Let's go back to the column. We need to make sure that the column functions the way it should. Hide excluded components. Okay, it's obvious that in my connection I was a naughty boy. I didn't exclude the remainder of the bolts that are associated to it. And I need to make sure that they are. So those three there, exclude them from the bill of materials because I don't want to see them. And I forgot to put my trim in, so let's put that in. Utilities, trim. So we've got our column trimmed, and what we also need to do is reattach our member sketch. Okay, so there's the top level member sketch, and we need to go down into the member that contains it and make those equal. So that's got that member sketch in the part, and I've just snapped it on, which is what TSD automatically does for you. I just detached it earlier. Alright, so let's just run this again and make sure that everything that's supposed to be hidden hides. So what we're left with is just the base plate and the column, and of course we can actually show the excluded components and bring them back so that they're gone. Let's go back to the drawing sheet and let's go through this process again. That's right, I set this one up the top, didn't I? And now we should be able to hide the remainder. I'll just remove that so that that's not shown. You can set this up any way you like as far as your detailing goes, because this is a template to suit yourself. Alright, so now I'm just going to hide the bolts, hide excluded components in drawing, so now the bolts should disappear, and voila. With this, do whatever you like as far as the detailing goes. You know, I can put a center line in there, remove that, run a dimension up over the top, you know, put in the thickness of the plate, dimension the overall, and you can pretty much just say goodbye to that drawing template very shortly. And in here I've got my section AA. There's no label, but you can have it so that it's got a label. I'm just showing you how to do this. Obviously a couple of centers so I can dimension the holes for my plate. Also too, there's certain notes that have to go into this drawing that you want to use when you do a member lock. There's a note that we can use. I'll show you that in another demonstration because we're running out of time. What I want to do now is just add this to the library. So that template itself is up to you and how you want to detail it so that you've got it. Okay, so now I don't need to come back and create another base plate. Now in that base plate connection I could have put a shear key in there, I could have put a couple of gussets and, you know, stiffen that thing right up. I could have put some bracing cleats around it to make it look really interesting. Now I'm going to show you one of those in a sec. So now the connection itself is inside. We've got ourselves a member. Okay, we're ready to go. We've got plate updated, plate drawing updated, member drawing. Need to make sure that that's updated, so let's just do a check. No, that's still got some of the old crap in there. We don't want that stuff coming into our templates. Okay, so we've got ourselves a dimension that's running somewhere. Doesn't look like it's actually attached to anything, so we'll just put that on. Alright, you can set that up any way you like, any way you feel. The bombs for TSD come in the top right hand corner when you do a member lock, so just make sure that when you're creating your templates that you allow enough space. Now I've just put my column over here on the left hand side. What I need to do now is just make sure that there's nothing pointing outside of this into another area, and I'm now looking at this connection and I can see there's an XX here, but that's okay. We've got our base plate and it's probably stored in the right folder to match. If we go File, Find References, we can see that everything is contained inside the folder to which the member resides, which is good. Now there's an audit that happens to this before we upload it, and it'll tell you if you've got file references pointing out to other areas that you've trimmed and you want to add this to the library. You actually have to break those and then reattach them. So now I'm just going to upload the member to the member library. So if we go Structural and we go Columns, where are we, Columns, and we go TSD, hit the tick. So now that's done a quick audit, and now it's uploaded it to the library. So now we've got it in the library. Alright. Now, because it's in the library, we can reuse it now over and over and over again to suit ourselves. Alright, so that pretty much shows you how to create a member to add to the library. Now I've got my member in here. Let's just show you how the member can come in. So let's just say on the front plane of the main assembly, and if we had a driving sketch, I'd use a driving sketch assembly. I'm just going to drop in some lines, different lengths. Doesn't matter how long they are. It's up to me and how I want them. I can then go in and go to my TSD members and go Columns. It's appended my column, which I've just done at the end. If I click Sketch, my sketch contains 4 entities. Right, it will automatically put new columns on every line one by one using my library component as I see fit. And of course they're all driven by my sketch, so it means that if I change my sketch, move it, drag it, change the height of it, so does my column when I rebuild it. So you can see the advantage of that. Now these are all new numbers, okay? New instance mark numbers. So every column is different, they're the same. We have duplication and we have copy as well, but in this instance, because all my columns were different, I ended up with different new mark numbers and everything. So it's worked quite well. All right, so that's the actual column member that's been added. Now consider that hand railing, all that sort of stuff is done exactly the same. So if I was to just use an existing component, I'm just going to draw a basic sort of frame. Now with your members, because you've actually got some sort of a process in play, you can put equations. You probably find that I've just done right angles on everything here. That's okay. You can go diagonals. All right. So I've got an error in there, but for all intensive purposes, it's quite a simple process, and they all work the same. So you saw me put 4 columns in. We go into members and we go to our hand railing. We've got hand railing in our library. Just pick the hand railing. Same thing. Sketch. And now we can end up with different handrails populating a sketch, and it's the same process. I'm just using library components to create myself a sketch, create myself a hand railing project, and it automatically, because I've got equations in there, works out which way number of stanchions we've actually got inside our hand railing. The number of stanchions is determined by the maximum spacings of say 2 meters, I think, in this instance. So you can see it pretty much populates that fairly quickly off one model item. I've now got 8 different handrail instances that have occurred, and I have a driving sketch that I can manipulate that will allow me to change the shape or the form. If I can grab it, there we go, of the hand railing, just to show you how it works. And if you do another rebuild, those stanchions should come together. Pretty handy, hey. Obviously with each one of these handrails I've also got a drawing that needs updating that I've just put in, but the good thing is I don't need to go and drop views in. I've already got a template that I can modify to speed the process up. So now you can see the power of how you can create items from libraries. Now I created that connection that you see there, basically in 15 minutes. You can go crazy with connections, create any connection you want and add it to your library, and then you can reuse it over and over again. You can see how I used a plate, inserted the plate into a connection, created a member from the connection, and now the next library component that I won't demonstrate because we run out of time is to pretty much upload an area. So if you go to upload area, you can do the same thing in there, set up a structural filter. Any kind of building or system, you can actually create buildings. So instead of having structural discipline, you could have a building discipline or a mining discipline, and in there you could have cancel that. I don't know where that came from out of the blue. And you can set it all up in your filters. Now the filters, so just make you aware of it, these filters occur at the area level, they occur at the member level, and they also occur at the part level. If you go into TSD projects and you go into the library filter manager, in here you have your discipline. So if I was to select in here and go BE, you'll see I've got beams and then I've got my supplier. Now the way it works, say for instance I went vendor, and I think I've got CR for crusher, and in there I've got a TSD crusher that we've modelled up for TSD purposes. You could potentially have, the name of a crusher. It could be from Metso, or any of the other suppliers. If you've got a screen, you could set it up so you've got a screen from Schenck. If you're a miner, you do mining engineering stuff, and you're in the mining industry, it's very handy for filing things in different disciplines. Basically, predominantly, if you're just doing structural stuff, you've got all the structural components in here that you can add in for your library filters. Now, when you create these filters, they're used so that you can find your library items fairly quickly, okay? Because at the end of the day, the last thing you want to do is go through previous projects looking for models so you can put it in your current project. And if you've done that, believe me, that is slow and it's painful compared to what I'm offering with TSD here. Along with the automatic filing, it's a no-brainer, just saves a lot of time. Okay, well, we've hit our hour mark, and I'd like to pretty much thank you for your time, and I hope you've got a very good understanding of how you can reuse components in TSD to be able to produce items fairly quickly. Obviously the documentation and drawing side of it we'll probably cover in another webinar. If you've got any questions, please send them to support at the Steel Detailer. I want to thank you for your time, for sitting here and listening to me waffle on. Hopefully you'll gain something out of this and probably make a decision about changing the way you work. If you're already using TSD and you're here learning it, great. If you're a customer that's looking at this and you're thinking about buying TSD, please, if there's anything that you want to know, send us an email and we'll sure as shit show it to you. Best thing to do is see this live, okay? If you see it live, and I'm sure it's just going to reinforce your decisions in the future. So thank you for being a SolidWorks user, and thank you for being online, and look forward to seeing you online again at the next webinar next week. Enjoy the rest of your week, guys. Thanks for your time.